Okay, so in the second part of Lesson 7 for Unit 4, we are going to talk about how to write the rule for an arithmetic sequence. So this little key concept at the top describes the nth term of an arithmetic sequence, with the first term being a of 1 and the common difference d, and it's given by this rule. So this rule gives us all the notation we need to be able to work with to write a rule. All right? So this right here is what we call, it's just the general form for what's called an explicit rule. Okay? And what an explicit rule does is it gives us an equation that we can substitute into to find any term in a sequence. Okay? The other type of rule, not represented here, is what's called a recursive rule. So if you look down at number 3, or example 3, it's going to talk about how to write a recursive rule. But the main thing is that every rule we write, we need to know two things for sure. We need to know the first term, and we need to know the common difference. So those are the two variables we use to represent first term and common difference. And with arithmetic sequences, these two things are the easiest thing to find. First term in this sequence we're given is 70. If we look at our sequence, the sequence, to go from one term to the next term, we add 7. So our common difference is 7. So what a recursive rule does, okay? What a recursive rule does is it says, here's the first term, and here's how to get to the next term. And you repeat, and you repeat, and you repeat. So recursive means kind of like recurring, happening over and over. So to write this recursive rule, we're going to say, it's going to start with the same a of n, okay? And it says take your last term. So if n is the current term, n minus 1 is the last term. So what this means is, this a of n minus 1 means the last term. Take the last term and add 7. So the recursive rule, what this means in words is, it says take the last term, a of n minus 1, and add 7 to it. So in a recursive rule, we give that rule part of it, and then we say where the first term is 7. So what this rule describes is it says, start with 7, and to get to your next term, add 7, and then add 7, and then add 7. So a recursive rule isn't really great for finding the 50th term or the 60th term. It's good for describing a sequence, but not for finding terms. So a recursive rule, I think, is a little more rare. An explicit rule is going to be a little bit more useful. So that's what I'm going to show you next. So an explicit formula, we still need the same pieces of information. We still need to know the first term. We still need to know, we still need to know the common difference. So it says a subway pass has a starting value of $100. After one ride, the value of the pass is $98.25. 2 rides, it's $96.50. 3 rides, $94.75. We're going to write an explicit rule to represent the remaining value of the pass. So it's kind of like a gift card. You have a balance, and then that balance decreases when you make purchases. So the starting value of this sequence, the first term, we start with $100, and we have to decide what is happening. It's going down. How much is it going down by? Well, some simple math there would just be to take 100 minus 98.25. That means each ride on the subway is $1.75, meaning our common difference is negative 1.75 because this value is decreasing. Okay, the value is decreasing. So for me to write this as a rule, you always start with this a of n to find the n term, or nth term. We are going to say, take the first term and do what with it? So take the first term, 100, and what are we doing with it? We are subtracting. That value is going down. You're subtracting from the last term, n minus 1 term, and multiplying by 1.75. So what this n minus 1 means, and I really want to emphasize this, what this n minus 1 means the last term. the term before it. Because if we're on term 5, the term before it was 4. If we're on term 20, the term before it was 19. Okay? So this rule represents the remaining value. Okay? Represents the remaining value. So knowing first term, common difference is the big idea here. Now, example 5 is going to be important because we're translating from a recursive rule to an explicit rule. So it says an arithmetic sequence is represented by the recursive formula a of n, so the nth term, is the last term plus 12. That's what this means in words. Take the last term and add 12. If the first term is 19, write the explicit formula. So that's, again, we have to know first term, which is given to us, is 19, and we need to know the common difference. So from this recursive rule, the common difference is positive 12. Positive 12. Because it says, take the last term and add 12. So the explicit rule, to find the nth term, you take your first term and you add last term times 12. So following this at the top, this n minus 1 is consistent in every explicit rule we write. The things that change, and I'll put this in blue, the first term and the common difference. Those are the things that will change. Those are the things we will have values for, we'll have numbers for. So it's important to know first term, common difference, how to write that. So, guided practice. It's a long one. Examples. This video is going to get a little long. But since we don't have a lot of paper and pencil practice, this is an excellent time for you to be able to just work through these on your own, pause the video. Might take you a few minutes, but then when you're ready, resume the video and just check your answers. I'm not going to spend a ton of time on this, but it's a good thing for you to just look at and check. So I'll try and kind of show you the answers slowly, but good chance for you to pause the video, check your answers. Okay, so for the guided practice, what I'll do is I'll just kind of explain. In number 1, this is what we did in the first video, just a verbal description and then find the next 2 terms. So if you want to pause the video to double check your answers, I'll give you a second and then I'm going to move down to number 2. Okay, number 2, telling whether it's arithmetic. That means adding or subtracting the same number to get the next term. And then what's the common difference? So A and D were not arithmetic because we have plus 7 plus 8. And then for D we have, down 4, up 4, down 4, up 4. So you're adding or subtracting 4, but you're not adding 4, you're not just subtracting 4. So that's not arithmetic. C and B are both arithmetic, and it shows a common difference of positive 2 and then negative 6. For number 3, there's another one. Good idea to pause the video. There's a lot going on, but I'm asking you to write the recursive formula and find the 9th term. So that means for part A, take the last term, and I'll highlight. Take the last term, A of n minus 1, and add 6. And your first term is 3. So it's extending that rule out and writing a recursive rule. So I'm going to move to the next page. It's a lot of, which is actually more guided practice, but I'm actually, just going to go through these just like I would an example, a normal example in the notes. So for number 4, it says an online auction for a guitar starts at a bid of $200, and each new bid increases the price by $10. So we've got to write an explicit formula and find the price of the guitar when we get to the 12th bid. So for this, the useful information is the first term in our sequence, the starting value, is 200. So that concept of a starting value. Our common difference, the rate of change, the price is increasing by 10. So that means the common difference is positive 10, since we are adding 10 to get our next price. $10 bid, $10 increments of bids. So our rule, the nth term. So this is the explicit rule. Explicit rule says you take your first term, you add or subtract the number of the last term times the common difference. So that is our rule for this situation. Now, to find the price of the guitar on the 12th bid, that means we are finding the 12th term in the sequence. So when we substitute this in, we are substituting 12 in for n. So this becomes 200 plus 12 minus 1 times 10, or 200 plus 11 times 10, which is 200 plus 110. So the price of the guitar on the 12th bid is $310. So, writing a rule, substituting in to the rule to find a specific term. And then the last two examples, just review taking a recursive formula and finding the explicit formula. So this is just us looking at a recursive formula and saying, my two pieces of information I need, first term is 21. In this one, common difference is 2. So, our explicit rule, A of n, is our first term plus n minus 1 times 2. If our common difference is negative, this plus sign becomes a subtraction symbol, okay? So that comes from here. If that were minus 2, this would be negative. It would be subtracting the quantity, okay? In part B, first term is given to us. It's 2. Common difference is given to us. It is 7. So my explicit rule, take my first term, add n minus 1 times 7. And that's my explicit rule. So that's the idea. We're taking sequences and talking about starting values and rates of change, common differences. So now you're ready to finish up with some practice and the checkpoint for this entire lesson.